Assalamualaikum and good evening. We are from group A3. My name is UZMA AFRINA, BINTI HASRAMANI, metric number DE100179. I will present about the introduction for this experiment. Okay, first, what's the meaning of the voltage source inverter? It is a sort of inverter circuit that transform a DC input voltage to its AC equivalent with at the output. And then an inverter is used to convert the transform DC power into the AC power at the required of the frequency and voltage. Voltage source inverter also is commonly used to drive AC motor, especially at the three-phase system. In AC/DC power converter application, it deliver a great control performance and energy efficiency, as well as a current waveform and regenerative the operation. By varying the amount of time, the switches are simply switch on. The inverter may adjust the frequency of the output waveform. For the variable output voltage may be generated by keeping the inverter output constant and altering the input DC voltage. Unless the input DC voltage is remain constant, and then a variable output voltage may be generated by the altering the inverter to gain by using the pulse width modulation PWM control technique. And then next, three-phase DC or DC voltage source inverter are widely utilized in a motor drive to yield the adjustable frequency and AC voltage magnitude utilizing different pulse PWM technique. For the experiment, we want to see the three-phase inverter can be operated either in 180 degree or 120 degree conduction modes by simulating on the MATLAB Simulink. For a three-phase inverter with 118 degree conduction mode, the switching of complementary and each phase is connected to either positive or negative terminal, and phase current are always continuous, same as a three-phase inverter with 120 degree conduction mode.
Hi everyone, my name is NITHIYAAN Raja. My matrix number is CE190043 and I am a team member from group A3.5. So today I would like to present about 180 degree conduction mode in BSI. So let's we look into the simulation parameters. The MATLAB block model used for this three-phase voltage source inverter with pure resistive load for mode 180 degrees converter in this situation are shown as below in the table. So the components that we are using is a pulse generator, switch, DC voltage source, power graphic user interface and a resistor. So the switching PWM conduction mode. So for the pulse generator we are using 180 degrees conduction mode. The switch we are using is MOSFET and the parameter set for DC voltage source VS is 250 volt. The power graphic user interface we are using a continuous mode and the value of resistor we set into 10 ohm. So let's we look into the simulation model design. So based on the lab sheet, we are required to construct the modeling of VSI using MATLAB Simulink simulation for 180 mode as shown in the below figure. So the simulation design we use is this. So let's we straight jump into the simulation. So this is the simulation that I did for this 180 degree conduction mode. the power graphic user interface that we are using is a continuous mode. Then the switching component used for this voltage source inverter are MOSFET transistors, which was divided into three segments, which is segment 1, 2 and 3. So segment 1 consists of switch M1 and M4. Segment 2 consists of switch M3 and M6. Segment 3 consists of switch M5 and M2. So at any given time, both the switches are in the same segment should never be closed at is lead to battery short circuit, failing the entire setup. So in this scenario should be avoided at all times. Other than that, the MOSFET transistor fed into the PWM signal with a 60 degree phase delay from each switching signal from M1 to M6 to be conducted in 180 degrees mode. So as you can see, this is the parameter for the pulse generator. So as you can see, the period that we are set is 1 over 10,000. So the frequency of this signal is 10 kilohertz. So the pulse width set into 50% because 100% width is a total of one period. So 50% is a 180 degrees conduction mode. So for the first signal, the phase delay we set into 0, and the following signals 60 degree phase delay has been added to create a simulation for this 180 degrees conduction mode. So let's we look into the graphs. So first graph we are looking is a switching pulse graph. So let's we run the simulation first. Okay, as you can see, this is the graph that we produce. So let's we zoom in the graph and we look into the phase delay. So as you can see, this is the phase delay, which is 60 degree. So which will eventually add up until from M1 to M6. So these are the switching pulse that we are using for this 180 degrees conduction mode. So let's we look into the line voltage and the phase voltage graph. Okay, so this is the line voltage graph that we have produced for this 180 degrees conduction mode. So as you can see, these are the line voltage graph that we have produced. So as you can see, the peak is voltage. So let's we look into the value of the peak voltage. Okay, so let's we insert a tool called data tips. So as you can see, this is the value that we have produced for this line voltage, which is 247.524. So the peak voltage that we have used during the parameter that we have input in this simulation is 250 volt. So the graph produces 247.524 volt. So let's we look into the negative peak. So as you can see, the value produced is same, but the value are in negative cycle, so the value is in negative. So let's we look into the phase voltage. So this is the phase voltage graph that we have produced during this simulation. So as you can see, this is the phase voltage graph that we have produced. So let's we look into the value of each of these steps in this waveform. So let's we insert the tool which is called data tips. Okay, as you can see, we produce the value of 123.762 voltage for this peak. So let's we look into the second wave, because this is the first wave that it has produced. So as you can see, the value of this wave is the peak value is 165.016 voltage. So as you can see, the second step that it had produced is 82.5081 voltage. The third is in negative cycle, so the value that it produces is negative 82.5081. So as you can see, the negative peak value is negative 1.65.016 voltage. So that's all for this simulation. Okay, so now let's we look into the results of the 180 degrees mode voltage source inverter. So the first graph that we are looking into is a VSI switching signal from M1 to M6 waveform. So this is the graph that we have produced during this simulation. So the phase delay that we have set at the pulse generator has been shown in this graph. So the total conduction, the period of this waveform is 360. So the pulse we have set into 50. So this is so we can say that this is an 180 degrees conduction mode. So let's we look into the line voltage waveform. So this is the line voltage waveform that we have produced from this simulation. So as you can see, this is the V peak, which is a Vs. So the value that we have produced is 247.52 524 volt. So for 0, the value is 0. So for the negative cycle, we have produced the same value with the negative voltage. So as you can see, for these three graphs, we have obtained the same value. So let's we look into the phase voltage waveform. So this is the steps that I have told earlier. So this is the value for this voltage. So for at the peak, we have produced 165.016 volt. For the second step, we have produced 82.5081 volt. So as we can see, this is the negative cycle. So the value that produced on the positive and the negative is same. As for the negative cycle, there is a negative symbol in front of the value. So this is what happened during this 180 degrees mode voltage source inverter conduction mode. So these are the results that we have obtained during these simulations for the signal, the switching signal, the line voltage and the phase voltage. So these are the graph and these are the explanations and the formulas that we will be using. So that's all from me. So I would like to pass this presentation to my friend. Thank you.
Assalamualaikum. My name is ZARIFAH binti ZAKARIA, matric number DE190110, and I will be the person in charge to simulate circuit of 120 degree. As you can see here, this is the circuit for 120 degree, which we have changed the phase width to pulse width to 33.33%. This is the switching signal of S1, S2, S3, S4, S5 and S6. The difference between here is 60 degree, and we know from here that there is no step to the waveform. Next is line voltage. This is line voltage for VAV, VBC, VAB, VBC and VCA. We could see steps at the waveform, which is different from the switching signal. This is the phase voltage. This is VAN, VBN and VCN. From here we could see steps to the waveform, which is lesser than line voltage, but still has some step to the waveform, different from switching signal waveform. And that is the gain that I get from the simulation of this circuit. That is all from me. Thank you.
In the conclusion, there are 6-step inverter was developed by using the MATLAB Simulink to evaluate the inverter operation and to generate the MOSFET waveform based on the simulation result are shown. The MATLAB simulation result for each phase to neutral and line-to-line voltage switching signal were presented. After that, we can obtain the corresponding waveform by analyzing the output from voltage source inverter with specific input voltage. On the other hand, there are two conduction mode, which is 118 degree and 120 degree. Was produce the voltage output waveform for phase to neutral voltage and also line to line voltage will be shown in the MATLAB Simulink. Based on the observation, we can see that the signal is connected and they release simultaneously through the transistor to be well ignite and commute in a 118 degree mode inverter. However, the 118 degree conduction mode, this commutation interval is not provided, and therefore there is still risk of immediate short circuit of the DC voltage source. At any point throughout the circle, we can see that the voltage of just two output terminal linked to the DC voltage source is determined in a 120 degree in the mode conduction. Then it could be examined and observed that each MOSFET conducts 120 degree period or duration, and then when off for the net of angle, which is we use 60 degree in a cycle of alternating output voltage. we can see that phase voltage has one negative and positive power, which always had the same 120-degree duration. That's all for me. Thank you